VLSos here. This is a lesson on angles and the triangle sum theorem. I have an angle drawn here. I have an arc between the two lines or sides of this angle. And what we measure when we refer to an angle is the amount of opening between the two sides. The two sides of an angle intersect at what we call the vertex of the angle. So this point where the two sides connect is called the angle's vertex. And these lines are the angle's sides. Now we can measure the amount of opening, and we have a system to express or write down or enumerate our measures when we measure angles. There's a few different ways to do it, but one of the most common ways is to use a degree measure to measure angle opening. A full circle has 360 degrees in it. So we can measure angles that are less than a full circle and express them as a measure of degrees. We have names for angles that have different sizes based on their degree measure. This angle has a fairly small degree measure. We call it acute. And if the measure that we can symbolize M is greater than 0 degrees, but less than 90 degrees, then we say it's an acute angle. An acute angle is small. It has to be something greater than 0 degrees, or greater than a measure of nothing, but less than 90 degrees, which is a quarter circle. If an angle has a measure of exactly 90 degrees, which would be a quarter of a full rotation or a full circle, then we say it's a right angle. And the measure, if we call it M, in a right angle is exactly equal to 90 degrees. I'm using the degree symbol, which is a tiny little circle that is superscripted up and to the right of the number. It's kind of like a unit symbol, and it tells us that the number is a measure of degrees when we use it. If we make a right angle, instead of an arc, we can put a right angle arc, which is like a little box near the vertex of the angle, which is a symbolic way of stating that that angle is a right angle when we use that particular symbol. An angle that is large, and large means that it's greater than a right angle's measure of 90 degrees, but at the same time less than 180 degrees, which is a half circle. We call this kind of angle obtuse. An obtuse angle is any whose measure is in between 90 and 180 degrees. And we have a situation in which an opening can be measured to be exactly 180 degrees. Which makes the angle look like a line. But if it's an angle, we could call it a straight angle. And the two sides line up to make it look like a line. And we can compare this to starting with one side and rotating all the way around so that it doesn't look like an angle at all, but our opening, we could imagine, went all the way around to create a full circle of 360 degrees, and we could call that a full rotation. So we no longer see the two sides because the second side opened up all the way around and is now resting exactly on the first side, or the starting point. Let's draw a triangle. A triangle is a shape. All shapes have angles and sides. A triangle has 3 sides and 3 angles. There's a truth that's been discovered about the angles of a triangle called the triangle sum theorem. And the triangle sum theorem states this: the sum of the angles of a triangle is 180 degrees. Every triangle, if you add up the 3 angles inside of it, then you're guaranteed, no matter what individual measure the angles are, the sum of all 3 is 180 degrees. It always works. So for example, if we had this triangle and we knew a measure of one angle to be 30 degrees, one to be 100 degrees, and we didn't know the measure of the third angle, so we could say it had a measure of x. We have an obtuse angle and an acute angle, but we know that if we add these 3 angles together, it's guaranteed to be 180 degrees, which then allows me to make an equation. If I add the 30-degree angle and the 100-degree angle and the measure of x, which is the third angle that I don't know, then the 3 of them together will be 180 degrees, which creates an equation that I can use to find the unknown angle. I'm going to add 130 together and then subtract from this side 130 degrees. What I do to one side, I must do to the other. When I subtract 130 degrees, it'll cancel out, leaving x by itself. And on the other side, 180 minus 130 is equal to 50 degrees. I was able to use the triangle sum theorem to find the measure of that third previously unknown angle.